So last week we were using the Titanic dataset. So for those who did not um, had JMP last week, I hope you all do. We opened the file, we downloaded the file from module 11. So the data was in module 11, right? Titanic dataset. Some of you already had the same dataset from different courses. And then I did some modifications to the data types and saved it as JMP file. And I'm going to open it right now. Okay. So if you want to be a good person in analytics, the first thing you need to know is to dive into your data, to understand the meaning of each and every field in your data, right? So it is not just you have some data and you jump into analyzing it using regression or exploring it or getting the averages and some information about your data. It's not about that. Analytics is a mix of science and art, and the more experience, the more intuition, the more knowledge of the context you put into the analytics project, the more information, the more useful, the more powerful you are going to be. Okay. So we talked about the content of this data set, and we talked about we want to predict, or we want to see if we can predict the survival of the passenger based on some other information that we have here, right? Okay. So the first step when we want to start working with our data after understanding the meaning of the column. So passenger ID, it's a serial number for the passenger numbers. Survived, this is whether a passenger survived the Titanic going down or not. The class of the passenger, the name of the passenger, the sex of the passenger, age, number of siblings, whether they had kids, the ticket numbers, fares, how much they paid, the cabin, and something called embark, right? And we want to use this information to predict the survival of the passengers. I told you that even though JMP picks automatically some data types for you based on the type of data. So if it is text, it's automatically set as nominal. If it is numbers, it's automatically set to continuous, and so on. You should look at the data yourself and decide the data type you want to use. So for example, for the passenger ID, I accepted continuous because it's a continuous number that starts from 1 all the way up to 500 or something, right? Or 800. And then survived is a number, and it was marked as continuous, but I changed it into nominal, right? Because in survived, we have two categories only, either survived or did not survive, 0 and 1. And therefore, it makes more sense to use it as a category or class rather than using it as a continuous number. Same thing I continued here for all the fields, right? Whenever I feel that a field is a class or category, I changed it either into nominal or ordinal. Okay, and we talked about that last week. So the second step, and you should spend as much time as you need in this phase. So spend some time grasping your data, understanding your data, the relationships between your data, and so on. The second step is to start exploring your data, looking at things like, is your data correct or not? Do you have problems in your data? Does your data need cleaning or not? Okay. So two of the most major problems that we face with data are two things: missing values and outliers. Okay. Missing values are bad because, let me tell you why missing data is bad. I already talked about that, but let me explain that in a nutshell, right? I told you several in the last week and even the week before is that a way to do prediction, if we want to predict a variable based on another variable, it's something like building a line graph between the two variables. So for example, in the example we have here, if I'm trying to predict survival is not continuous, so that wouldn't make much sense. if I'm trying to predict something like house price based on the area of the house, okay? And then I'm going to have some areas here. So area of 1,000 feet, 1,000, right? I have some data that I collected from websites like Zilli, for example. 1,000 feet. I have another one for 1,100 feet, 110, 110, and so on. So I have a number of houses, right? And corresponding to each area of the house, I have house prices. For example, for the 1,000, I have one price, and I have one house that was sold at $200,000, right? And another one that was sold at $210,000, right? For the 1,110 feet, I had one that was sold at 210,000. Another one that was sold at 212,000. Another one that was sold at 216,000, right? So now what happens is if I have missing values in the area section, so some of the houses, the areas were not reported, then I'm going to end up with gaps here. So for example, if I don't have enough areas between 110 and 1,500 feet, right? Then I have a gap of values here. And therefore, when I'm trying to build my line, when I'm trying to go through, build a line, my line will not be accurate. It will be accurate in these two values, but in this gap, the gap with missing values in the area section, okay, the line may be not so accurate. So I won't be able to create a good line, right? So the problem with missing values in a variable is the model that I will create will not be, I will not have enough data. I will not have enough data to build an accurate model, okay? So this is why we hate to have lots of missing data in our data sets, okay? We hate to have missing data in our data sets because it's like losing data. We will not be able to use this missing data in doing any modeling or any analysis in the future, right? So always the first step we do after understanding your data is to explore whether we have missing values or not in our different fields. So to do that, JMP and other softwares provide us with a way to summarize our data and look at missing values in our data. So if you go to the Analyze tab in JMP here, okay, and then we go to screening, okay, and we go to explore missing values, okay, we can start adding some. No, don't do that to me, please. I fixed that yesterday. Okay, let me check. File. Windows specific. Okay. Okay. So again, analyze, and I'm going to close it down and restart it, guys, because I have to do that in order to make this change like active. Okay. Right. So again, I'm going to open that, and I'm going to go to analyze, and then I'm going to go to screening, and then I'm going to explore missing values, and then select the fields you feel have missing values. In this case, I can select everything. So I will select survived. Passenger ID, I don't care. Passenger ID is just an ID in my data. It's not a variable of any meaning, right? So I will not use passenger ID. Passenger ID has no meaning in my data. It's just numbers, right? Right. And then the P class, and then Name doesn't matter as well. I don't care about the name of the passenger. 6, age, siblings, pouch, ticket, fare, and cabin. Okay, so I added a bunch of variables here, and then I will click OK, and I will get an analysis of the missing values here, guys. Right? You can see that I have problems only in one variable, the age variable. Okay, the age variable has 177 missing values. That means almost 20% of my 20% or a little bit less of my data is missing. 177 missing values. This is bad. What this tells you is when you are building a model, it's very hard for you to use the age in building the model. Okay, because if you include the age in building the model, you are excluding 177 data points from building the model, right? So we avoid using age when we are developing our model. Okay. However, if you believe that age is really important, then then you can find some way to fill in these missing values. Okay. In statistics and analytics, we have a method called imputations. Okay. Imputation is a technique that allows you to fill missing values based on the other values in the same record. So for example, if you open the JMP file here, and I have a missing age in row number 6 here. Okay. Imputation allows me to find a value to put in this age based on the other values in the row. So based on the passenger ID, based on survived, based on P class, based on male, based on the other stuff, fill in the age field, right? Now, the problem here is you need to understand your data to understand whether you can predict the age based on the other values or not. So age is an independent variable. Age is something, a feature of a human being. It's like this human is male or female. So I don't think there is a way, I don't believe there is a way to predict a person's age based on the kind of ticket this person got and the number of siblings and parenthood they have. So I don't think it's possible. Okay, I don't think it is possible. But if we have missing values in a different column. So for example, if we have a missing value in survived, okay, then we can predict survived based on all the other information in the column, right? So whether you use imputations or not, whether you try to identify the missing value or not, depends on the type of the variable itself. What does the variable represent? If it is a very basic demographic variable like age, it's very hard to predict that based on the other variables. So we will have to accept the missing variable values in this case. There is nothing we can do to change the values in this case. Okay. So for the age, we will not include the age when we are developing our models further. Even though you can, for other variables, you can select to use imputation to fix this problem. The second missing variable here is cabin, and you can see that a cabin has 687 missing values. Okay. Now, this is something dangerous to interpret, because this is where your experience as someone working in the business will have an impact, right? So the question that we need to answer is, what does this mean? What does having this huge number of missing cabins mean? Does it mean that someone did not enter the value, so these are actually missing values, or are these cabin numbers missing because some passengers did not have any cabin, so they were residing together in a common place, they were sitting together in common place, for example, if in one of the classes, right? So to investigate this further, we can do two things. We can do a search on Google and find out if all the passenger on the Titanic had cabin numbers, or some of them were not in cabins. Or there is another way to look at it. If we look at the class, the passenger class here, the P class that you can see here, and compare it to the cabin, you will find that all of those with a class 3 don't have associated cabins. So if you look here, you will find that anyone in class 3 and some in class 2 don't have a cabin, right? So 3s don't have a cabin, 2 as well. Okay, it looks, for me, it looks like only class 1 are the people who had cabins, right? If you look, you will find that. Okay, so here, this is an important thing. This is an important note to note, right? There is a relationship here. The missing values have a pattern. There is a pattern in missing values. The missing value depends on the class of the cabin the passengers are residing in. Okay, and in this case, we need to we can fill in these cabins by putting a 0, for example, or putting another sign that to represent that these people are not in any cabin. These passengers are not in any cabin. Or if you notice the similarity between the class and the cabin, that only P class has cabins, all other classes don't have cabins, you can omit the cabin, because the class and cabin are the same thing. If you are in the first class, that means you have a cabin. If you are not in the first class, then you don't have a cabin. So we can ignore the cabin variable with confidence, because we understand that it is correlated, or it's strongly related to the passenger classes, right? Are you following, guys? Everyone following? Any questions here? Okay, so this is why I'm telling you, data is not just putting it in numbers and doing the work and that's it. This is a very bad way to do analytics. The best way to do analytics is to keep your eyes open and use your understanding of the context, right? If we didn't notice this relationship between the P class and the cabin, then we could have imputed or inserted values in cabin based on some imaginary reason in our heads, and we end up with the wrong type of variable. But because we noticed this relationship between the P class and cabin, we can say that we can omit the cabin variable with confidence. Okay, with confidence, right? Right. So this is about the missing values. When you are creating a missing value report in your project, or in the future when you are working on a real project, you need to explain whether they can be fixed or not. As I mentioned, this is a basic demographic variable, so I wouldn't think of correcting it. This is something that you should get from the passengers directly. There is no way for us to predict the age. And for the missing values of the cabin, we explained why these values are missing. We explained it by talking about the relationship between the cabin variable and the class variable. Okay, so that's the first area of exploration. This is the first thing I explore after understanding my data. Without understanding your data, you cannot do this. It's very hard to do this. Okay, if you have questions, guys, feel free to stop me. Okay, the second thing we will look at is the outliers. Okay, outliers mean an outlier is a value that is way beyond the range of values in the variable, right? So for example, here in the age, we have ranges. Let me look at, I will show that to you, right? In order, I will show you how to explore outliers first, and then I will explain to you what they mean and their impact. Right? So outliers. If we go to, if you want to look at the outliers in the best way, a way that is very common and very popular among analytics people, is we go and use a graph that is called box and whisker graph. Box and whisker graph. So if we go to the graph section here, okay, and then we go to graph builder, right? Graph builder is a very powerful visual tool in JMP that allows us to quickly create charts. Okay, So I'm going to click on this box whisker plot, and then I'm going to insert some variables. So I'm going to insert, let's say, the survived variable. Okay, survived variable is supposed to have only two values, right? Okay, so you can see that it's drawn as a box. So it has two values, either 0 or 1. There is nothing else. So there are no problems here. So let's use a continuous variable. So I'm going to replace survived with the fair, for example. So I'm going to, or age. I'm going to drag the age and put it here. Get rid of that first. It's all drag and drop. Okay. Okay, let me put it in the Y better. Okay, right. So when you draw a variable on a box and whisker, we get up with this neat graph. This graph shows us the minimum age that we have here. So at the very bottom, this is the minimum age, and then we have the median or average of the data, and then we have the maximum within certain statistical boundaries, and then we have some values outside these boundaries, right? So we have an age of 80, we have a little bit 74, and then the normal range, most of the range of passengers is from 0, right, all the way to 66. So this is the normal range of ages, and then we have ages above this value. An outlier is a value that is very far away from the top range of the data. So from this line at the top, if you have a piece of data that is very far away, then this can be considered an outlier. Okay. Now, why are outliers so bad? Okay. Outliers are so bad for several reasons. Okay. Let me show you an example of an outlier first. So if I go to my data and change one of the ages, one of the missing ages here, I will change this to 200 years. There is no one who is 200 years old, right? So I changed that to 100 years old. Okay. And then I will do the graph one more time. Okay. So I'm going to put age again. I'm going to click the X and whisker. Okay. You can see that this is the normal range of our ages, and then this is one very far away age. This is a 200 years age that I added. Okay, so why are outliers bad in analytics? They are bad for two reasons. Number one, they can indicate error in entering data, right? So we know for sure that in 1918 and up till today, there is no one who can live for 200 years. So when someone entered the value of 200 years in the data set, that means he made a mistake for sure. It doesn't make sense that someone is 200 years old, right? So we need to go back to the data and try to correct this error, either by checking the data, looking at the original data and re-entering the value, whatever, right? So when we have an outlier like this, the first thing we do is we investigate whether the data is correct in the first place or not. If it is not correct, then we need to fix it. That's the first. This is the first problem. The second problem is if you have an outlier, a value that is far away from all the other values, this can have a negative effect on the predictive model that we will create. That can have a negative effect on the model that we will create. Okay. Again, I will explain that to you very fast using a whiteboard. And okay, right. So in the same graph that you see here, right? This is the line that describes the relationship between the area and the house price. If we have an outlier in the area, so for example, I have for the 1,000 feet or 1,100 feet area, I have an outlier. I have a price of $500,000 or $600,000. Okay. What happens is that this line, the line that we draw, will change because the line depends on the data. So the line we draw will be like this. Okay. And therefore, our predictions will be off. Okay. Just because we have one outlier in our data or few outliers in our data, there was a difference between the best model in the blue line, okay, and the red, the second model, which is the red line. There is a big difference here, guys, and this can create an unstable model or a bad model for us. Okay, so outliers can cause problems, even if they are real data. Even if they are real data, they can cause problem and destroy our model. Okay. So how do we manage outliers? There are two things to do. Basically, if I am doing the analysis, I get rid of outliers. I remove outliers from my model. And the way to do it is you can right click on this dot. So I can right click here. Okay. Okay. And then I can go to rows. Okay. Go to row editor. Right. And I can either change this to 100 age. So where is this? Okay. Right. I can edit it by right clicking and editing the value. Rows, and then okay, I can change the color of the row to red, for example. It should be changed here. Okay, and then I can exclude it from my analysis. So if I click exclude, now this row will not be part of any further analysis, right? So I can exclude the values with outliers. This is the best approach. This is the best approach that I use in order to manage outliers in my data. In very few cases, you want to consider outliers. If outliers are important in your analysis, then we will consider them. But if they are not important, you want to create, your goal is to create the best model, then usually we exclude outliers from our analysis. Okay. So we talked about outliers and we talked about missing values so far. Does anyone have any questions so far, guys? All right. The second step is to look at the properties of our variables. Properties means their averages, their standard deviations, and so on. So this is basic again, right? So we go to analyze and then distribution, okay? And then we look at the variables we want to look at. So for example, I'm interested in survived. I'm interested in the class. I'm interested in the sex. Sex is not important. It's males and females, so I don't think it's important. We can look at age. We look at fear. Okay. And then we press OK. All right. And we will look here. We are going to have some information about all the variables. This is very important. This is exploring what our variables look like, right? So survived, we have 1 and 0, and these are the frequencies. Okay. The class we have 1, 2, 3. Perfect. No problems here, right? Age, the distribution looks very nice between 0 and maybe around 80 or something. Okay. Siblings, you can see that most passengers have no siblings, and the number goes down. Parents or have kids, same thing. Okay. Right. And for the fear as well, you can see that the fear, most of the fear is between 0 and 50 maybe, and then it's a little bit less as we go on. Okay. Now, if you have a small number of data, if you have data that is less than 50 rows of data, then the shape of these variables will be problematic because they are not normal distributions. These are not normal distributions. But if you have more variables than 40 or 50 rows, then you can work with them. There will be no problems here. Right? So this is important. You look at the average, the standard deviation, all the information regarding your variables. Okay, so I find that by going to analyze, right, and then distribution. Okay, is everyone following so far? I hope so. Now the last step in exploring our data is looking at relationships among the variables. What are the relationship between sex and survival? Okay, between age and survival, between fear and survival, between all the other variables and survival. We need to look at these relationships, okay, because this will tell us if there is a model, if there is relationships in the data that we can use to predict survived or not. Okay, so to do that, we are going again to go to analyze. Most of our work will be in this section, analyze section, analyze. Okay. Okay, and then we are going to use the fit x by y selection, this one, fit y by x. Okay, we're going to select the variable we want to use as our dependent variable. So in this case, it will be the survived. Okay, and then the other variables we want to check against survived, we'll put here. So we can put the class here, we can put the sex here, we can put age, we can put siblings, we can put Porsche, and we can put fair. Okay, right, and then I'm going to click on OK, right? And this is going to show us the relationships between the variables, right? So you can see, for example, the relationship between class and survived. You can see that a survival went down with class. So class 1 had more survivals than class 2, then class 3. So it seems there is a relationship between the class and between the survived. Okay, so when we are building a model in the future, we need to look at the relationship between P class and survived. If you look at the relationship between sex and survived, same thing. Females survived much more than males, and therefore there is a strong relationship here between the sex and the survived. If we look at the age, okay, you can see that the older the age, the less likelihood of survival. Okay. Okay, now I want you to look at the difference between the first two graphs and the third graph. Okay, notice the difference between the first two graphs and the third graph. The first two graphs were between two category variables. So B class is category and survived is category as well, right? And therefore the graph looks like this, looks like squares for the categories, right? For the continuous variables, age is a continuous variable. Right, and therefore it was drawn like a scatter plot, as you can see here. It was drawn as a scatter plot. Okay, now there is very important thing to look at in order to see if there is a real relationship between age and survived, if there is a real relationship between age and survived, which is this p-value, this value in red that you can see here, 0.0234. Okay, this is called significance value, okay, or p-value. Okay, it's either called p-value or significance value. If it is less than 0.05, if this value is less than 0.05, that means there is a relationship. If this value is more than 0.05, then there is no relationship. Okay, so this is a very important value to look at. It's called p-value or significance. Okay, right? So because this is less than 0.05, we can assume that there is a relationship between the age and the survival. Okay. Okay. If you continue, you can look at the sibling, this sibling SP, right? and it looks like there is a relationship. But if you look at the significance here at the bottom, you will find it's more than 0.05, and it's not in red, right? So there isn't really a relationship here. Okay. In Parch, there is a relationship. So it seems that when you have kids, you are more likely to escape death in this area, right? And it is significant because the P is less than 0.05. Okay. And then the fare. Okay. Again, it's very clear that the more the price you paid for your ticket, the more it is likely for you to survive. You can see the P square is very small here, right? So unfortunately, those who paid more survived more than those who paid little on Titanic. Okay, so this is important because this is how we explore relationships among different variables. Okay. Any questions here, guys? Any notes? Anything any insights that you want to share about this? Okay, so as you can see here, guys, the exploring the data takes most of the time of working on the project, right? Yes, Brenda. JMP is very similar to SPSS. Yes. Right. So exploring the data, you should spend as much time as you can. Okay. For those who don't know, guys, SPSS is the IBM version of JMP. So IBM has a software called SPSS that's also very powerful. For me, I prefer to use SPSS. Okay, but it's much more expensive than this. We don't, and it doesn't have a trial version as we do here. Okay. Anyway, right. So make sure, guys, you spend as much time as you can exploring your data, diving into your data. Trust me, I have been doing this for years. I have been doing this for years. The more time you spend on exploring your data, working with your data, the more benefit you are going to get, the more useful insights you will get from your data. Okay, so don't say no. I'm going to jump to doing my my model and that's it. Okay, don't ever do that. Spend as much time as needed, as much time as you feel needed to explore your data. Use graphs, use any kind of tools you have to explore and dig deep into your data. I will show you 0.05. This is okay. So if it's a 0.05, it's your call, Leslie. Some people consider it to be less than 0.05, but it's never it can never be 0.05. There is no way on earth it's going to be 0.05 because this is statistics, Leslie. So statistics, you will always have several decimal points. So there is no way on earth it's going to be 0.05. Adriana, I shared one of you last week. I will share it with you again at the end of this class. Okay. Right. So you will never get a 0.05 value. Don't worry. Okay. Okay. And then this 0.05 is arbitrary. This is something we agreed on as people working in statistics. We call this the p-value, and it is like standard now. But some people use different values for p-values. But let's stick to 0.05. Let's stick to 0.05. Right. Now, this is the minimum things to do to explore your data. There are other things that we can do to explore our data. Okay, so this is only the minimum. We can also always go to graph and start looking at relationships between the different variables, right? So for example, it makes sense that there is a relationship between the class and fare. For example, lower classes, the third class will cost less than the first class. So let's explore if there is a relationship between the P class and the fare. So I'm going to go to, there are two ways to do it. I will show you both ways. If I go to the graph builder, and then I'm going to do a relationship between the class. So I will put the class here on the x-axis, and I'm going to put the fare on the y-axis. Okay, right? Okay, you can see that there is a relationship. The fare for the for the first grade, for the first class is different from the other two classes. You can see that here, but let's even explore better. So if I click on this, right, this line, okay, right, this line shows me that kind of relationship. You can see that there is a relationship, especially in the first fair, but then the second and third classes are very close together. So they are not the same thing. The classes are not the same as fairs. People pay different fares, and there are other factors that impacted fare in addition to the class, right? Because you can see that the second class and the third class are very close to each other, right? Right? We can look at, for example, we can get rid of the porch, and we can look at if people have kids, will this impact? No, there is no relationship between porch and fare. You can see it's going down and up. Okay. We can look at age and fare. Okay, nothing, right? It's still vibrating. So we use graphs to look at the relationships between the different variables that may be interesting to us. Okay. A final thing that I will talk about exploration, not the final thing in total. The final thing about exploring our data, about exploration of our data, is looking at the correlations. A correlation relationship in statistics is a relationship between two variables. If one variable changes, the other one will change. Okay, so like the relationship between the area of the house and the price of the house. If the area of the house increases, the price of the house will increase as well. Okay, this is called a correlation. Okay, correlation is very similar to what I showed you by fit y by x, the graphs that I showed you here, okay, a while ago. But the only problem with correlation is that it can only happen between two continuous variables. You cannot do correlation between a nominal or categorical variable and a continuous variable. So if we go to analyze here and we go to multivariate methods, okay, and I will click multivariate here, okay, I can select several values. So I need to make sure I'm selecting numeric values, continuous values. So I need to select, for example, the age, okay, and the fare, right, okay, and then I'm going to press OK. Okay, and this is going to show me the relationship between the age and fare. So there is very small correlation here, guys. You can see that 0.0757 correlation, very small correlation, which is something we already got from our graph, the graph we drew, right? We can click here and we can create a fit line that shows us the fit between the two variables. Okay, you can see it's very narrow fit, right? And it is not significant. This is a very small correlation, very small correlation. Okay, right? So after we are done with all of this great work, we are now ready to start building a model. We want to create a model to predict survived based on the variables we found significant. So we are going to predict survived based on the class, based on the sex, based on the porch, right, and based on the fare. Okay, so how do we create our model after the exploration? Don't ever jump to the model before cleaning up your data and before exploring your data, right? So we go to analyze. Everything is in analyze, right? And then we are going to select the fit model. Okay, fit model, right? And then we are going to select what variable we want to predict. So we are going to select the survived, okay, to be the y. Okay, and then we are going to select the variables we want in the model effects here in this bottom. So we will select the P class. We will select the sex. We will select the porch. and we will select the fair. Okay. Right. So before I run this model, there are few things that I want you to notice in the screen that you see in front of you. The first one you see is called personality. Okay, personality is what kind of model is going to be built. What is the algorithm that will be used to build the model? You can see that the option here is called nominal logistic. Okay, logistic regression is a kind of regression, a kind of modeling we use when we have a categorical dependent variable. Okay, so survived is not continuous. Survived is either 0 or 1. Yes, survived. 0, no, did not survive. This is called a categorical variable or class variable. And to predict classes in analytics in general, we use logistic regression. The logistic regression is one of the most common ways of doing that. So this is why we are going to use nominal logistic regression in this case. In another example that we will do after that, you will see that this can change to be something else. Okay. Now I'm going to run my model and we'll see the model that is created, right? This is the outcome of running the model. Okay. You can see that the most powerful effect, the most powerful variable to predict survival is the sex of the passenger, right? This is the most powerful effect, and you can see that it has a 0 p-value. It means it's very powerful in predicting the survival. This is followed by the p-class. The p-class p-value as well is 0, so p-class as well can be used to predict the survival of the passenger. And then the other two things, Parch and fair, are not significant. Okay, the p-value is greater than 0.05, and therefore they are not significant, right? So I have a question here. When we did the relationship between the variables, Parch and fair were significant. They had an impact on the survived, right? Why did they change to non-significant now? I'll answer the question for you guys. When you include multiple variables, when you have multiple variables in your model, the relationships among the variables can impact the significance of some of them, right? So here we are using 4 variables at the same time, and there are relationships between fair and class. There is a relationship between Parch and class, and so on. And therefore, the importance of these variables diminished because of the existence of the other variables. So this is pretty common in analytics. Yes, it is more than 0.05 and therefore not significant. Exactly, right? Yes, Michael.
You know, I was just throwing something out there because it's a ship, and we've talked about this in another class, I think, but you know, there's that saying, women and children first. So would sex be considered an outlier because it's out on a ship? And I mean, it's just given. If you're a woman or a child, you're getting in the boats. You know what I mean?
Yes. So yes, you are 100% correct, Michael. But this is not called this is not an outlier. An outlier is a value within a variable. Okay, so if one, like I showed you, an age of 200 within age, a sex that is neither males or females, some third gender in the case of this Titanic ship, and so on. This is a way to explain your model, right? So based on this result, I can say yes, it makes sense that the sex is the most powerful predictor of survived, because on the Titanic they saved. We know that historically, we know that they saved men, they saved women and kids first, and therefore we expect that sex played an important role in saving passengers, right? So you can use this the result that we see here to explain the result, to explain why the sex and class, the class are the two most important factors in survival on the Titanic, right? So they are not called outliers. They are ways to explain your results, right?
Cool. Thank you.
No problem. Now, the other very important number that I want you guys to see here is the R square. Okay. R square is an important number in statistics in general and in analytics. R square describes the power of our model, how powerful our model is, how strong our model is, right? So here is point R square can go between 0 and 1. Okay, R square can be between 0 and 1. 1 means it's a perfect model, and 0 means it's the worst model in universe, right? So here you can see that R square is 0.3. That means that our model is below average. This is not a great model. It's useful. It does explain survival somehow, but it is not a great model. It is not the best model out there. And a good R would be around maybe 50% or so, right? 0.5, but 0.3 is below average usually, right? I don't want to dig deeper into statistics to explain what R square means in statistics, but let's put it like this. R square represents how significant or how significant the independent variables predict the dependent variable. Okay, so you can say that the independent variables only predict 30% of the dependent variables. So P-class, Sparge, Fair, and Sex predict only 31% or 0.306 of the survived variable. Okay. Again, usually we are looking for something more than this. Okay, in analytics, right? Right. The other numbers are important, but again, they are very deeply involved in statistics. So I will not be going deeper into them for your own benefit, guys, because this is not a statistics course. This is a business course, so I won't be going too deep here. The important numbers I want you to know are the importance of the variables. The R square is very important because it tells you whether your model, you can use your model in real life to predict survival in Titanic or similar ships or not. Okay. And the third number is these numbers here. We won't be using these numbers in the course, but these are also very important. Why? Because these are the equation that describes the relationship between the different variables. So if you want to predict survived for a passenger on Titanic, we use these values in order to predict the survived variable for a single passenger. So if John was on the Titanic and we want to know if John survived or not, then we are going to use these values with John age, John sex, John Fair, his class, and so on, and predict whether John survived or not. Okay, so this is called the parameter estimates for our model. Okay, if you are using it in real life to predict something that is meaningful, then they are important. These are very important. Right? Any questions for this example, guys? Because I'll get you to try one on your own. Okay. So again, dig deep into your data. You need to dig deep into your data. Right. So let's use a different. Let's go and use a different data set, and I will let you play around with it for a while, 20 minutes or so, answer your questions about the data, and then we will work through it together at